I'm Asdrubal. I'm the CEO of FactoryPal, and I will be giving you a glimpse into what we are doing. So we are a corporate startup, roughly 14 months in business, and we have a software as a service solution which is applying artificial intelligence to boost manufacturing in process industries. So first of all, what is the problem we are trying to address? I mean, there are different pain points when it comes to production, starting with the operators in the shop floor not having the right level of transparency. They don't have the right visibility in terms of all the parameters and how they interact together. And we need to think, I mean, many of these machines can be pretty complex. So they are dealing with 100, 500,000 of parameters. And also you have the issue of the operators having different skills level, newer generation versus older generation. And in general, lack of real-time information, and that is causing that the production lines are not running at the right level of efficiency. If we look at the productivity KPIs, and we have one classical, typical, which is used in manufacturing, which is called OE, so the overall equipment effectiveness. The 100% performance is obviously very rarely achieved, so it is really not possible because you always have some loss. You also have some loss because of the quality of the material, and of course you always have planned downtime, maintenance, and product changeovers. But if you go from a baseline of 50%, which is not untypical, so depending on the industry, of course, it varies, but we are seeing 40, 50, even 60 is on the high end. There's a potential to increase this to at least 75%, which can be considered best in class. And here you can see some of the aspects that are really bringing that down. So you have unplanned downtime, and you have breakdowns, and you have the line not running at the right speed, so micro stops. So these are really things that can be addressed, avoided, and this is where we are trying to focus. So really bringing it from 50 to 75, or from 40 to 75. So significant potential to increase the performance and the output on the production. So how the solution look like? It's pretty straightforward. So we as a startup, we are being disruptive, and we found our niche, but it's pretty straightforward. So we're basically taking the data from the production line. So all the data that we can get our hands on. So starting with the actual production data. So what is being produced, what are the actual set points, what are the actual settings that have been set on the machines, combined with product specifications and the work orders. And all these come into the cloud where we apply our algorithm. And this algorithm, which is applying different machine learning methods, is determining the optimal settings, so the optimal center lines. And these optimized settings of the parameters are being pushed real time to the shop floor. So the operator has a mobile app in their hands, can be iPhone, can be an Android device, and they get these recommendations real time from our algorithm, and then they apply those settings, and that's it. So by applying these settings, they will see a significant increase in the performance and the output, and this is happening all the time. So every hour, they are getting 1, 2, 3 recommendations from our solution. And at the same time, of course, there are other functionality for the process engineers in the shop floor, analytics, and also having a view on the solution. So at the end, we have a solution that it's really, we like to talk about hybrid intelligence. So it's not only applying machine learning, artificial intelligence. The algorithm is learning from what the operators are doing. So it learns from what they did in the past, and it also learns from their input and what they are doing, accepting or rejecting our recommendation. So it's really a very nice symbiosis of the machines with the actual human input. And then, of course, big data, internal things. I mean, I already mentioned that we are getting data from different sources, starting from the machines in the shop floor, but also from different systems. And number of parameters, it really doesn't matter. It can vary depending on the industry we are applying the solution. But very important is we see our solution as an augmenting companion. So it becomes an integral part of the daily workflow in the shop floor for these operators. Going just a bit deeper into the solution. So we are targeting two main personas. So you have the process engineers in the factories, and we also have the machine operators, so really the colleagues, the people in the shop floor managing and setting the machines. This is, I mean, we won't have time for a demo, given the short time, but this just to give you a flavor. These are actually screenshots of the solution of the mobile app. So you can see here, the recommendations we are providing are very specific. So they are specific not only to the production line, but also to the particular product being produced. So you can see here, just as an example, anyone can relate to this. So there's here a pressure parameter. And we are saying, okay, change this parameter from 3.3 bar, which is the current value, to 3.5 bars. And that's it. So the operator will accept the parameter. When they accept it, nothing needs to be done, because we will know they implemented, because we are constantly reading the actual set points from the machines. But if she or he decide to reject the parameter, we want to know why. So now come sorry about that. This screen, which is actually requesting the feedback. So we want to capture why they are rejecting the parameter. And there might be good reasons why they're rejecting. I mean, there's a reason why they're there. And the idea is that 75–80% of the time they're accepting what we are pushing. But in the case they reject it, we will capture, so why don't you agree? So we, in this case, this is an example from tissue, so production of toilet paper. So they say, okay, I'm not agreeing to this because I'm seeing that the paper is being torn, or there's a paper tear. In addition to the actual parameters pushing that we do all the time, the operator has also, for the first time, the product specifications electronically. Normally they have this on paper. Now they have here directly on the hands in the mobile app. They can also see the actual KPIs from the production row, how many units have been produced, how is the line running, speed. They can also see the details of the work orders. And before I leave these slides, we are talking not only about electrical parameters which can be read through direct connectivity. We're also talking here about mechanical parameters that are also relevant and have an influence on the process. So we can also capture those and make recommendation on the mechanical settings. In case you're wondering, just a few words on the ML-based algorithm, how we are doing this. We actually capture all the data scientists. The more data they get their hands on, the happier they are. So we are looking at all possible parameters, can be more than 400, and we look at which subset of those parameters can have an impact, so have a significant impact on the performance. So it can be a subset of 30, 40, 20, depends on the industry. So again, in the case of the industry where we started, which is toilet paper, we are looking at 30, 35 parameters. And then the recommendations evolve around these 30 parameters. The algorithm is predicting a future OEE. So really looking, okay, what will be the OEE in the next 3 hours? We work in 3 hours windows to get this output. And you can see in the graph, what we are predicting is actually very, very close to the reality. And I also mentioned this feedback mechanism. So when the parameter is rejected, we also capture that, and that fits the algorithm to make it even better. Just high-level solution landscape, typical IoT AI solution. I mean, we have a gateway, so we need to collect the data every second here, or every minute from directly from the production lines. This comes to the cloud. From the cloud, we provision the apps, the mobile app, the web application. And we also have a connectivity to the customer ERP or manufacturing execution system we need the data, for example, the product specifications and the actual work order. And I'm almost done. And is it working? Yes, it's working. These are actually value proof points from one existing customer. You can see here we have been consistently increasing the OEE in the last 5 months. And here you see a median of 6.1 percentage points. Just to give you an idea, so 1 percentage point increase in OEE, depending on the industry, can represent quarter or $500,000 more profits for that line, and can represent also 100, 200,000 cost reduction. And imagine you multiply that across different lines. And very quite compelling is the also reduction of the machine downtimes. And we have seen in our customers even more than 50% reduction of machine stops. So that's where we are today, and I'm done.